Hello and welcome to Maths with El Profelo, doing some elementary number theory and working on some exam style questions. So this question is to prove that any natural number n greater than 6 can be written as the sum of two integers greater than 1, each of the summands being relatively prime. Okay, so in other words, we're trying to say, right, that we're going to let n be a natural number, right? So we're going to let n be a natural number with n being greater than 6. And we're going to say, let's say that n is equal to x sub 1 plus x sub 2. All right, we're trying to show that the greatest common divisor of those two numbers is going to be 1. All right, so in essence, that's what we're trying to show. Okay, this feels like it's going to take the situation of considering cases and doing a proof by exhaustion. And the reason I say that is that we can think of a case where n is odd, right? And we can think of a case where n is going to be equal to 4k, so it's going to be even and divisible by 4. Okay, so we're going to say k is going to be an integer, right? And we could think of a case where n is going to be 4k plus 2, that it's even and divisible by 2, right? So this feels like it'll take care of everything based on being greater than 6. Because if we're greater than 6 in terms of even numbers, I could have an even number of 2 and an even number of 4, and so that's where this idea comes into play. We have a case where n is odd, and maybe we need to consider more things, but let's work through this and see where it leads us. Okay, so if this is the case, right, and we're going to say that x sub 1 and x sub 2 are also integers because we're finding their greatest common divisor. Okay, so if n is odd, okay, if n is odd, then and n is equal to x1 plus x2, we know that if we let x sub 1 be equal to 2 and x sub 2 be an odd number, we're going to be able to write any particular odd number in this form, because we know that an odd number plus an even number will be an odd number. So this seems to take care of the case for our odd situation, right? The x sub 1 being 2, x sub 2 being an odd number takes care of everything. Okay, which in this case, x sub 2 would need to be n minus 2, because then we would have 2 plus n minus 2 is equal to n, and that's going to take care of everything. Yeah, that seems to work. Okay, our next case, if n is equal to 4k, right? So if n is equal to 4k, right, well, n being equal to x1 plus x2, right, if I think about this, well, if x sub 1 is equal to 2k plus 2, and x sub 2 is equal to 2k minus 2, then x sub 1, 2k plus 2, x sub 2, 2k minus 2, add them together, I get to 4k, and that seems to satisfy what I need with 4k. Okay, then if n is equal to 4k plus 2, so n equals 4k plus 2, we can play around with this and say, well, n is going to be equal to x1 plus x2, if x1 is equal to 2k plus 3 and x2 is equal to 2k minus 1, then we would have 2k plus 3 plus 2k minus 1 is equal to 4k plus 2, and that would satisfy that in terms of getting things in terms of n. Now we just have to show that we would have these as being relatively prime if n was greater than 6. If n was greater than 6. So let's think about our possible numbers just as an example. Our possible numbers just as an example here. And we're going to have 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 spots here. But let's say that we had a particular value, right? That we had a particular value, and let's say that we had a value where this number was 2k. Okay? Well, then here would be 2k plus 3, 2k plus 2, 2k plus 1. This would be 2k minus 1, 2k minus 2, 2k minus 3. Okay? Now, the possible equivalence classes that we would have from 2k minus 1 to 2k plus 3, that's going to be 1, 2, 3, 4, 5 distinct equivalence classes, right? So we would be able to have, let's say that this is equivalent to an equivalence class of 0. Well, here would be an equivalence class of 1, here would be an equivalence class of 2, and an equivalence class of 3, and an equivalence class of 4. Okay? So what we see here then is that our natural numbers greater than 6 are going to have at least, or not at least, are going to have 6 distinct equivalence classes, which will be relatively prime to each other, possibly. So now we've got to figure out, how can I be sure that these are relatively prime? Okay? Well, if I have odd numbers, right, and I have 2 and some odd number, those are relatively prime by definition, because 2 does not divide into an odd number. Right, so that is met there, and it's left to you to determine how you would write that. Okay, if I had 2k plus 2 and 2k minus 2, right, and I thought about what would be represented there, right, well, if I had 2k plus 2, right, and I would say, well, here I have 2 above, right, and 2 below, so I would be looking from here to here, right? Well, once again, there's 1, 2, 3, 4, 5 particular numbers there, right? And we could say, well, if I'm going to have an even natural number, what's going to happen? If I'm going to have an odd natural number, what's going to happen? And we'd say that it doesn't seem that this will work with plus 2 and minus 2, because that's going to give us an even number between our two, right? So if we change this to say 2k plus 1 and 2k minus 1, then we would be able to say, okay, well, if I said, here's my number, right, are these two going to be relatively prime? And we'd be able to say, okay, well, for sure, 2k is even, which means that 2k plus 1 is odd and 2k minus 1 is odd. Okay? And we'd say, well, is it possible to have two consecutive odd numbers be not relatively prime? And the answer to that is no. Two consecutive odd numbers must necessarily be relatively prime, because if we consider our smallest possible odd number, 3, right, we would have 1, 2, 3. Each of these 3 would be relatively prime to each other, right? With the exception of the, because this would be an odd number, an even number, and an odd number. and on division by 3 they would each have a different remainder, and I would not have anything in common between this term and this term. Okay? Now, if I consider then the plus 3 and the minus 1, same idea, right? I'm going to have two odd numbers, right? So minus 1 and the plus 3. Would I be relatively prime there? And the answer to that, once again, is yes. I would be relatively prime, because what I would have is, with being n greater than 6, right? With being n greater than 6, let's say that this was divisible by 3, 2k minus 1. Well, then if 2k minus 1 is divisible by 3, 2k plus 2 is divisible by 3, but not 2k plus 3. Okay? And if 2k minus 1 was divisible by, let's say, 4, well, then that would be an even number. And we know that 2k minus 1 is not going to be an even number. If 2k minus 1 was divisible by 5, let's say, well, then 2k minus 1 would be divisible by 5, and then 1, 2, 3, 4, 5. 2k plus 4 would be divisible by 5, but we're not going to be considering that because we have 2k minus 1 and 2k plus 3. So that seems to work out for us. We'll leave it to you to determine how you would write all that information out.